Our topic is the Cambrian explosion. We're going to be discussing things like some of the hypotheses that led up to the event, as well as the availability of ecological niches that came about, and the selective pressures due to a predatory environment.
There were a few hypotheses leading up to the event. There was a mass extinction early in the Cambrian period just before the Cambrian explosion event. One hypothesis is that the warming environment at the end of snowball Earth caused cool water to rise due to melting ice. The melting glaciers may have later contributed to an increase in some essential nutrients, such as phosphorus, which would allow for an increase in biodiversity later on. Another hypothesis states that less oxygen-consuming bacteria in the water allowed for an increased oxygen availability for potential biodiversity. Oxygen was essential for many metazoans to maintain metabolic and physiological processes required for aerobic respiration. More oxygen availability could also be a potential driving force towards multicellularity. Aggregation occurred where the cells group together and then form one multicellular unit. Another factor contributing to the Cambrian explosion is the availability of ecological niches.
The same upwelling of cool water, which caused oxygen-consuming bacteria to become extinct, allowed for the creation of a variety of marine environments. This wide variety of temperatures and depths is thought to have provided a reasonable explanation for the adaptive radiation that occurred during the Cambrian explosion.
Another explanation for the adaptive radiation and extensive speciation that occurred during the Cambrian explosion is the new presence of a predator-prey environment and thus an increase in selective pressures on organisms. Defensive strategies such as burrowing and the development of hard exoskeletons developed at this time. New research suggests that a sudden urge of calcium in oceans caused by volcanically active mid-ocean ridges caused marine organisms to develop exoskeletons and thus hard parts. One example of this development of hard parts as a protective mechanism was Wolwachsia. Wolwachsia is a species that lived on the bottom of the sea during the time of the Cambrian explosion. Wolwachsia had hard parts and development of spiky scales on the top of it and a very soft underside, which could be a protective mechanism.